let me just start again. It won't take time. So this is we're talking about the DC motor which you use in the lab. You control it to spin in either direction. Those motors can be controlled by changing the voltage input to them. So as the voltage increases, these lines, which are the torque speed curves, will keep moving parallel as shown here. And so clearly at a larger voltage, you'll have a larger stall torque or larger speed. But you need to always be below the maximum rated voltage, otherwise you will burn the motors. Okay, so that is how you control the motor, by changing the voltage. But you really can't sit there turning knobs. What you need is a circuitry which will do that. And that is done by what is known as an H bridge. Okay, why is it called an H bridge? Is because the way it is wired looks like an H, as you can see here. So it consists, the circuit consists of 4 switches, S1, S2, S3, S4. This is your motor in question. So you can see that that is connected to all the switches in a particular fashion. Now, what you'll do is, if you close S1 and S4, you pretty much cause the current to flow in the direction shown. So positive is to the left, negative is to the right. If you open S1 and S4 but close S3 and S2, then the current will flow this way. So it will be exactly opposite to the direction shown in the middle figure, which means that now you can get it to spin clock or counterclockwise. So that's the basic idea of how an H bridge controls the direction of motion of the motor. The next thing we are interested in is speed control. How do you control it to go faster and slower? We know that changing the voltage will do that. And so the way speed control is achieved is through what is known as, it's actually called pulse width modulation. Pulse width modulation. Okay, so the H bridge, which is this circuit which you used in the lab, which closes switches, fires at there's a certain time constant associated with that circuit. It can switch these switches on and off quickly. What we do here is we keep the voltage to the motor constant. So when I say V, it's basically this voltage. It's always connected to voltage and ground. But we control how fast we'll turn these switches S1, S4 in pairs, either S1, S4, or S2, S3, on and off. Okay, so as I said, there is a certain frequency at which you can control them. So let's say that there is a time constant T, and you decide to keep the switches closed for 20% of the time. So 0T, 2T, and 3T is the time constant, and you keep the switches closed for 20% of the time. Then what will happen is that this is clearly the supply voltage. Then the result of the switches and the supply voltage is that the net voltage which the motor will see, so this is the V motor, is going to be 20% of V. Okay? And so you'll see that the voltage is 20%. If you want to go 50%, you just change this frequency, switching to 50.5 T, and you'll have 50%. And that's pretty much what the H bridge does it. Now, you need a circuit for that because there is high frequency components, really hard to build this by hand, but you can also create an H build yourself. It just is not worth it. For $5, you can buy something which will do this for you. And you probably don't want to spend time making one. So this is the basic fundamental way in which an H bridge works to control the direction and speed of the motor.